Hi, this is Jason with MathTutorDVD.com, and today we're going to begin to talk about fractions. We're going to spend the next several sections talking about all sorts of aspects of fractions. This section is going to be sort of an introduction review of fractions, things that you probably have learned before, but maybe they're a little bit fuzzy, or maybe you haven't studied fractions much in a long time, so this is going to start from ground zero and we're going to go from there. I'm not going to assume that you have a lot of experience with fractions. And we're just going to build upon it one step at a time. And then after this section, we'll get into adding fractions and subtracting and all that stuff. The first thing I want to say before I really get started is don't stress out too much about fractions. A lot of people, even adults, have problems with fractions. There's really no good reason for it, though. The reason people mostly get intimidated or have a problem with fractions is just because they haven't worked with them enough to get comfortable. I mean, once upon a time when you were a kid, adding 6 plus 9 was difficult. Adding 5 plus 11 was difficult. But all that stuff gets easier as you do it more and more and more. And so you just need to see a lot of examples to know how to work with these things, to see what makes sense and what doesn't, so that you won't make mistakes. So we're going to do the same thing with fractions. All right, so what is a fraction? It's sort of a general review of things that you've probably learned before. What is a fraction? Basically, a fraction is used to describe when you have less than one of something. So you don't have a whole number of something. You may have a fractional part or just a part of something. So you're going to hear me talking about pizzas and pies a lot in this part, and a lot of classes do that. And it's a great reason that people do talk about that with fractions, because it just makes sense. So try to imagine a pizza. If you have a round circular pizza with all the pieces in it, you're said to have one pizza. But if I cut that pizza in half, that's fraction, right? Cut it in half, and I give this half of the pizza to somebody, we all know that we give half of the pizza away. If I cut the pizza 2 times, one up and down, one left and right, so I have 4 pieces of pizza, and I only take one piece for myself, only one of the 4 pieces there, then I'm said to have a quarter of the pizza, or I have 1/4 of the pizza. Those are fractions. You already have some experience with fractions, so don't stress out too much about fractions. We're going to learn how to write them, we're going to learn how to manipulate them and simplify them, but just remember you do have some experience. So, what is a fraction? I've already really told you, but I want to start from ground zero. So let's say I have this pizza. It's a round pizza here. Right? It could be anything, though. It could be a candy bar, could be a muffin, it could be anything that you can break up into pieces. And with this pizza, I cut it straight down the middle like this. Right? Just in 2 pieces like that. So there's 2 pieces of the pizza, 2 pieces total, but I don't take both pieces and give it to a friend. I only take one of these 2 pieces and give it to a friend. So what this means at the end of the day, since I only actually have 1 piece, I represent it as 1, but I need to somehow say that I only took 1 piece out of a total of 2 pieces. So there's my 2 pieces. So this is the fraction 1/2 that you all know and love. It's not anything more complicated than that. You have 2 total pieces that you cut the thing up into. That's the bottom number. We call this the denominator. And the numerator, which is the top number, is however many pieces I actually have. All right? So the fraction that you write is really going to be completely dependent upon how you chop the thing up and how many pieces you actually have. So if we wanted to take this pizza, instead of cutting it like this, like we said just a second ago, if we actually cut it into 4 pieces like this, and let's say I only give 1 piece away to my friend, then I'm going to have 1 piece out of 1, 2, 3, 4 pieces. So I'm going to have 1/4, 1/4 of a pizza. And just one more quick example. If I have another pizza, and if I divide it again into 4 equal pieces, those aren't quite equal the way I've drawn it, but you have to pretend here. And instead of giving my friend 1 piece, I give him 1 piece, 2 pieces, 3 pieces of pizza. What fraction of the pizza have I given him? I've given him 3 pieces out of 4 total pieces, so I've given him 3/4 of the pizza. So this is really all a fraction is. We have our numbers, 1, 2, 3, 4, 5. We have negative 1, 2, 3, 4, 5, our integers. And those are the whole numbers, the integers that we use every day. When you have less than one of something, you have to use a fraction, basically, to describe it. And so that's what we have here. Now, fractions can be negative. If I borrow 3/4 of a pizza, it's negative 3/4 because I really owe that pizza to somebody else. So you can still have negative numbers. Don't think of fractions as anything too special. They're just another number represented when you have less than 1. Now, I want to quickly give you a little bit of primer on a few different kind of fractions that you're going to run across. The first kind is everything that we've drawn on the board. It's called a proper fraction. Right? A proper fraction. So an example of a proper fraction would be like what we talked about, 1/2. The reason this is proper is because the top number, the numerator, is less than the denominator, the bottom number. So when you have a top number less than a bottom number, then it's called proper. Now, the reason we say this is because there's something called an improper fraction. And that is when you have the numerator larger than the denominator. Let's say we have 4/3. This is a perfectly fine fraction to have, but you just need to think about a little bit what this actually means. What it means is, I cut a pizza into 3 pieces, okay? Let's do that. Let's say I have a pizza right here, and I cut them into 3 equal pieces. So here I believe is going to be pretty close to 3 equal pieces. 1, 2, 3 equal pieces, right? So what this is saying is I go over to the table where I've cut this pizza into 3 pieces, and I take 1 piece away, 2 pieces, 3 pieces, but here I'm being told that I actually have 4 pieces. So what this means is that actually there's another pizza here that I've also cut into 3 pieces, and to get my 4th piece, I actually take it from another pizza. So it doesn't really make a lot of sense at first, and that's sort of why we call it improper, because most fractions that you're going to deal with, you're taking away fewer pieces than you have. But if I have something like this, then what it really is telling me is that I took 3 of my pieces away from here, and I had to take a 4th piece from someplace else. But in each case, I divided the pizza into 3 pieces. So what it really is telling me is, in this case, I have more than 1 whole pizza sitting in my desk or sitting in my chair. I have the 1 pizza from here, and then I took a little piece of another pizza. So when you have any improper fraction where the top number is bigger, basically it means you have more than 1 of something. And that is why we call it improper, because fractions really are meant to describe when you have less than 1. But you can certainly write it like this, and it just means you have more than 1 of something. Which brings me to the third kind of fraction that you'll need to know, which is called a mixed fraction. If I were going to write this thing in terms of a mixed fraction, I would write it as 3 1/3. 3 1/3. Actually, I said the wrong thing. I would write it as 1 1/3. So a mixed fraction is when you have a whole number out in front plus another little fraction sitting off to the side. So what this means, this mixed fraction, is that I have 1 whole pizza at my desk, that's this pizza, plus 1/3 of another pizza. That's what this is. Now, I've chosen this stuff very carefully because 1 1/3 pieces of pizza is exactly the same as 4/3. And I'm going to show you a little bit later how to convert back and forth between improper and mixed. So don't worry about that right now, about how to actually know when these things are equal to each other. That's okay. We're going to get to that. But for now, all I want you to know is that a proper fraction is when the top number is smaller than the bottom. An improper fraction is when the top number is bigger than the bottom. And a mixed fraction is when I have a whole number out in front plus some fraction over here. So that's really all I want to say here. Now, to get to the meat and potatoes of this course, we're going to need to go ahead and work a lot of examples. So what we're going to do next, I'm going to write a fraction down, and you're going to need to, or we are together going to figure out if they're proper, improper, or if they're a mixed fraction. We're going to write that down. And we're also going to find out if a fraction is undefined. And I'm going to get to that as we get to an example there. All right. First, let's go in and look at an example. What if I have 2 1/4 as a fraction? What kind of fraction is it? Is it proper, improper, or mixed fraction? Well, this is a mixed fraction. All it means is I have 2 whole pizzas plus 1/4 of another pizza. That's all it means. What if I have 5 1/9? This is also a mixed fraction because it's telling me I have 5 pizzas plus 1 out of 9 pieces of another pizza. All right? Let's say I have the simple fraction 1/4. What kind of fraction is that? That's a proper fraction because the bottom number is smaller than the top. The top number is smaller than the bottom. What if I have negative 3/4? Don't worry about the fact that it's negative. That's fine. Bottom number is smaller. The top number is smaller than the bottom, so it's a proper fraction. Okay? What about 7/4? Now in this case, everything's flipped over because the top number is actually bigger than the bottom, so this is improper. Okay? And what about 2/3? Top number is smaller, so that is proper. That's a proper fraction. What about negative 5 out of 1? That is an improper fraction because they're bigger on the top. So that's improper. Okay, what about 5/0? Now this is a special case, and I wanted to sort of wait until we get to this point. Don't forget, and I don't think I even really told you this here, fractions are describing the part that you have out of the whole number of pieces. This means that I have 5 pieces, but I didn't actually cut the pizza up into anything. I have 0 pieces that I cut the pizza up into, so I really don't have anything to begin with. It's really kind of a weird situation. Another way to think of it is all fractions are basically division. When you have a number on top and a number on bottom, it's exactly the same thing as writing division. So this is like 5 divided by 0, which is 5 divided by nothing. So anytime you have a 0 on the bottom, you can't divide by 0. You're going to get an error in your calculator. And so what you need to write down if you ever see a fraction with 0 on the bottom is this is undefined. Because how you would put this in your calculator is 5 divided by 0. You can't do that. And when you get into later math, you'll learn that this is infinity because you're dividing 5 divided by 0, which is divided by nothing at all. So you get a very, very large number. It's so large that it's really called undefined. So that's what we talk about. So one thing I want to drill in before we go any farther, don't forget that fractions are basically like division. Right here we have 1 divided by 2, but you can do that in your calculator and get a decimal, that's fine, but you're not going to really be able to divide that evenly. But if you have something like, 8 out of 2, then you can just do this division, 8 divided by 2, and that's going to give you 4, because 2 times 4 is 8. So don't forget that fractions are basically sort of division. So when you think of it in terms of division, 5 divided by 0, it's really not going to give you anything that you can put in your calculator. And we're going to talk about this whole thing about fractions being division here a little bit more detail here in just a few problems. All right, so let's say we have the fraction 8/7, or 8 divided by 7 is another way to think of it. Well, that's improper because you have a bigger number on top, so that's improper. Okay, and what about 0 divided by 8? Now, if a 0 is on the top, that's okay, because if you take 0 and divide by 8, you're just going to get 0. So that's something your calculator can do. That's a proper fraction. Because the top number is bigger than the top number is smaller than the bottom number. So it falls in line with the same thing as, this fraction here. The top number is smaller. The top number is smaller. The top number is smaller, so those are all proper. It's only when the 0 is on the bottom that when you try to do that division, you're not going to get anything, so it's undefined. Let's look at negative 1/50. Well, the fact that it's negative has nothing to do with it. The top number is smaller, so that is proper. It's a proper fraction. What about 9/9? 9 pieces of pizza out of 9 slices that I've cut. I have the whole pizza, in other words. I took 9 pieces, but I only cut it into 9 pieces. Well, it turns out this is improper. It doesn't mean it's a bad fraction or anything. It just means that the top number is not actually smaller. It's equal to the bottom. So if you have them both equal, just remember, for it to be proper, the top number has to actually be smaller. In this case, they're equal, so it doesn't really get you anywhere. All right. So let's review where we stand right now, because this section is going to be a whole collection of a lot of different things related to fractions that you've probably seen before, but we're going through it hopefully in a lot of detail here to really get you geared up for your algebra journey ahead. So far we've talked about a fraction being a part over a whole. You divide the pizza into 5 pieces, you take 2 pieces of pizza away, you have 2/5 of that pizza in your hand because you took 2 pieces out of 5 slices total. Okay? We've talked about the fact that you can have proper fractions, which are written like this, the normal way with the top number smaller, improper fractions when the top number is bigger, and mixed fractions when you have sort of a whole number of pizzas out here plus a fractional piece of a pizza left over here. We've talked about the fact that these improper fractions and these mixed fractions really are describing the same thing, that those are cases when we have more than one whole pizza, and we're going to learn how to convert back and forth between these guys here in just a few minutes. Okay, now a lot of times when you're looking at fractions, you would like to know if 2 fractions are equal or not. And that's really one thing that's really useful to be able to compare, because, you know, if I give you 2 jelly beans and I give you 2 pencils, it's pretty easy for you to tell me if you have the same number of jelly beans as pencils. You just count them. You have 2 of each, so yeah, you have the same number. But if I give you a fraction, it can be a little bit more challenging depending on what you have. So if I tell you, you know, I have, you know, 2/3 of a piece of 2/3 of a pizza, let's say, 2 slices out of 3 whole pieces, right? And I tell you that you have 2/3 of a candy bar, which is if you cut the candy bar into 3 pieces and I have 2 pieces, then speaking in terms of fractions, you would say these 2 fractions are equal, because basically out of 3 pieces, you cut each thing into three pieces, and I have in my hand 2 of those 3 pieces here, and I have 2 of those 3 pieces in my other hand. So yeah, I have the same amount of pizza relative to fractions, the same amount of pizza as I do candy bar, because I divided them both up into 3 pieces, and I have 2 pieces of each of those things after I divided them up. All right, now the problem becomes a little bit trickier if I ask you something like this. Is 1/2 equal to 5/10? And that becomes a little bit trickier, especially when you first start dealing with fractions, because you don't have enough experience to know what 1/2 and what 5/10 really look like, and if those things are related to each other, but you know that they might be equal, you just don't really know exactly how to do it. Well, the bulletproof way to do it would be to draw a picture. I mean, you could do that. So let's say for 1/2, we draw a picture. So I cut it into 2 pieces, and I take half of it away. So that's what 1/2 looks like. Now, if I take the same exact pizza and divide it into 10 pieces, well, there's that piece. Those 2 pieces. Okay, how many pieces do I have now? I've got 1, 2, 3, 4, 5, 6. Let's count the pieces now. 1, 2, 3, 4, 5, 6, 7, 8. Let me go ahead and draw another slice down here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 slices of pizza. You have to use your imagination a little bit that these are equal slices. Now, when I'm drawing on the board, it's a little difficult to make them perfectly equal. But even still, if you use your imagination, then I think you could agree that if I cut it into 10 pieces, let's look at what happens if I have 5 of those pieces. Well, here's 1 piece, here's 2 pieces, here's 3 pieces, here's 4 pieces, here's 5 pieces. So this is what it looks like to have 5/10 of a pizza right here. See the blue? It's basically the same as half of this pizza. So yes, they look completely different. 5/10 looks totally different than 1/2, but I've just shown you by drawing that they're actually exactly equal to each other. And that's the deal with fractions that confuse students at first, because they look totally different, so you don't really know which one's bigger, which one's smaller, or if they're even equal to each other. But you're asked to figure that stuff out on your homework and your test all the time, because you need to know how to do that stuff. Now, drawing a picture, it really is always going to work. You could do that. However, if you're drawing pictures all the time, you're going to be very slow. Plus, what if I give you a fraction like, 24 out of 36? So you have to draw 36 slices of pizza and try to shade 24 pieces. I mean, it's just not going to work. So there needs to be a better way. We've said before, if the denominator is the same, in other words, if I've cut the pizza in the same number of slices, it's easy to see if they're equal because the top numbers will be equal. What we need to do is figure out a way to basically change one or both of these fractions to give me the same denominator, and then I can make the comparison very easily. So here's how we're going to do that. And I'm going to teach you, and there's different ways to do this, okay? There's different ways to do this. But what I'm going to teach you to do is the following. Rewrite your fraction over here. So let's say, let me draw a little squiggly line here. Let's say I've got my 1/2 here, and I've got my 5/10 here. The number one rule of fractions, okay, is I can multiply or divide any number I want into this fraction as long as I do it the same to the top and the bottom of the fraction at the same time. You know, you got to think of fractions as a seesaw. You know, think of this as a seesaw. If I have a seesaw here, you know, out in front of me, and I've got two kids balanced on the seesaw, if I go up and put a bag of sand on this side of the seesaw, it's okay as long as I put the same weight of sand on the other side, then the seesaw remains balanced. If I put a truck on this side and I go and put a truck on that side, everything continues to be balanced. But if I just put something on one side by itself, well then the seesaw flips over. So same is true with fractions. I can multiply or divide the top and the bottom of this fraction by any number I want, but I have to do it to the top and the bottom. I have to do it to the top and to the bottom at the same time. Then the fraction remains equivalent, basically the same thing. So let me just show you by example how to do this without drawing a picture, how to figure out if these two things are equal. What if I multiply this fraction, what if I multiply the denominator by 5 and the top by 5? I told you I can multiply or divide this fraction by anything I want as long as I do it to the top and to the bottom. So if I do this, 1 times 5 is 5, and 2 times 5 is 10. So I have shown you that basically if I do this to this fraction, I get 5/10, which is exactly the same thing as the other fraction I'm comparing it with. So I have proven that these two fractions are actually equivalent to each other without actually drawing a picture. You wouldn't even need to draw this picture. All you need to do is figure out how to multiply one or both. Sometimes you need to do it to both of the fractions, but a lot of times you can just pick one of the fractions, multiply it by something to try to get to see if these things are equivalent. So what you're trying to do here is you're trying to look at the fraction and you're trying to say, okay, gee, here I have a denominator of 2. Here I have a denominator of 10. I want to try to multiply this fraction by something so that I'll have a denominator of 10. Well, 2 times 5 is 10, so I'll do that. But if I do it to the bottom, I have to do it to the top. So 1 times 5 is there also. Then I get my new fraction. This fraction, 5/10, I've just shown you if you draw it is exactly the same thing as 1/2, and so that's what makes sense there. So we've drawn a picture. I've shown you how that is true. And now for the rest of these problems, we're not going to draw any pictures. We're just going to do the math. So let's say we have a fraction 2/3, and we have a fraction 8/12. And I would like to find out if these two fractions are equal. Now, I could draw this fraction, cut it into 3 pieces and shade it, take 2 of the pieces away. I could cut this pizza into 12 pieces and take 8 of them away, and I could look at what I've shaded, but I don't want to do that. I want to try to figure it out by, by math. So the way I do that is I think I can work with this fraction because if I multiply 3 times 4, I'm going to get 12. You want to get the same denominator. So I'm going to do that. So 3, and I'm going to multiply the bottom times 4. But if I do it to the bottom, I have to do it to the top, right? So 2 times 4 is 8. 3 times 4 is 12. And looky here, 8/12. That's exactly the same thing as the other fraction I was comparing it against. So yes, they are equal. Those two fractions are equal. You would never really guess that they're equal by looking here, but I promise you, if you draw these fractions and you shade them, and you look at what you shaded, they're going to be the same amount of pizza in both cases, just represented a little bit differently, right? Okay, what you're doing here, I'm giving you a little bit of an advanced preview of what you're really doing here to compare these fractions is you're finding a common denominator. And a lot of kids, a lot of students, doesn't matter if you're a kid or not, a lot of students have problems with finding common denominator. People don't understand, why do you do it? Why do you need to find a common denominator? Well, this is the reason why, because you need to put these fractions on equal footing. If you see that you divide each pizza into 12 pieces by changing this one so that it's out of 12 pieces, then it's easy to figure out if they're equal because in each case I took 8 slices out of 12. Here it's harder to see because I only have 3 slices to begin with, so it's difficult for me to visualize it. But if I can transform one of those fractions so that I have the same denominator, the bottom number, in both cases, then it's easy to compare the numerators to figure out which one's bigger, which one's smaller. Maybe they're equal. All right, so let's go on to the next problem. Let's say I've got, let me pick a different one. Let's say I've got 5/8, and let's say I've got 3/4, and I want to try to see if those are equal. Well, I know because this is 4 and 8, I want to get the same denominator. If I multiply this one by 2, then I'll have the same denominator. So if I come over here and rewrite this fraction as 3/4, but I want to do some multiplication here. So let's multiply this guy by 2, because I'm trying to get to 8. Let's multiply this guy by 2. So what I'm going to have on top is 6/8. And look what I was comparing with 5/8. 6/8 and 5/8 are actually not the same. In fact, this is more pizza, because here I've divided the pizza into 8 pieces, I've taken 6. Here I divide the pizza into 8 pieces, and I've only taken 5. So in this case, all we're trying to see is if they're equal or not, so these are not equal. Not equal. So what you're trying to do is look at the denominator and figure out if you can find one to make it equal. Now let me show you another one. Let's say you have a fraction 0/3, and let's say you have 0/4. So here you divide the pizza into 3 pieces, you take 0 away. Here you divide the pizza into 4 pieces, you take 0 away. Both cases, I don't have any pizza because I took 0 pieces of pizza away in each case, so I have the same amount of pizza in each case. I have 0 pizza, I have no pizza. So these guys are actually equal because in each case I don't have any pizza. I mean, I take 0 pieces away, I take 0 pieces away. Another way to look at it is when you think of fractions as being division, 0 divided by 3 is 0, 0 divided by 4 is 0. So it's 0 in each case. 0 in each case. There's many times more than one way to do a problem, so I try to show you that. What if we had 3/4 and 2/5? 3/4 and 2/5. Now here it becomes a little bit more tricky. You see, in these problems up here it was pretty easy because I knew I could multiply 4 times 2 and that would give me 8 to get the same denominator. Here I knew I could take 3 and multiply by 4, that would give me 12. That's the same denominator. But here there's nothing I can do. I can't multiply 4 by anything that's going to give me 5, and I can't multiply 5 by anything to give me 4. But let me show you what you can do. Sometimes you have to think a little bit bigger. Like I told you, you can do the same thing to the top and to the bottom of a fraction as long as you multiply or divide it by the same number. And sometimes you might have to transform one fraction or the other. Sometimes you might have to mess with both of them. So here if I have 3/4, let me just finish this and then you'll see why I did it. What if I multiply this one times 5? So I have to multiply the top by 5 either. The top by 5 as well. At the same time I do that, I come over here and I take the 2/5 and I multiply that guy, not by 5, but by 4. But if I multiply him by 4 on the bottom, I've got to multiply by 4 on the top. So let me just finish and then we'll go over and see why we chose to do this. So 3 times 5 is 15. 4 times 5 is 20. Over here, 2 times 4 is 8. 5 times 4 is 20. Now you tell me, 15 out of 20 pieces or 8 out of 20 pieces? Which one is bigger? Well, this guy is bigger. 15 out of 20 pieces is bigger, and obviously they're not equal, which is all we really cared about, so they're not equal. Another way to write that is you can put an equal sign with a line through it. That means not equal. All right? So what we did here is we looked at these two fractions and we wanted to find a common denominator so we can compare them. You have to kind of find that common ground. But there was not, I couldn't just mess with one of the fractions and make it happen. But when you're doing this stuff, you can do anything you want to this fraction. So I multiplied top and bottom by 5. You can do anything you want to this fraction. I multiplied top and bottom by 4. I don't have to multiply each fraction by the same number. I just have to make sure that when I mess with this fraction, I do the same thing to the top and bottom of it, and when I mess with this one, I do the same thing to the top and bottom of it. The reason I chose times 5 and times 4 is because I knew that if I did this multiplication, I would get 20, and if I did this multiplication, I would get 20. And that allows me to compare the fractions. So that's what's called finding the common denominator. What we're going to find later, really, and that's why we're doing this practice now, is that later on when we add fractions, we're going to find out that we have to have a common denominator in order to add them together. If you don't have a common denominator, you just can't add them. And so the skills that we're building here with common denominators, and also in the next section that we're going to do even more with it, are really gearing up directly so that you can add them without any pain because they can seem to be hard at first, but trying to show you, you have complete freedom here. You can do anything you want. Here I chose 5 and 4. You could have chose something different, but this is a pretty good place to start. Now let's go ahead and do the last one of this problem type. What if I have 2 over 5 and 9/15? So in this case, I scan the denominators and figure out if there's anything cute that I can do. And I see that if I multiply 5 times 3, I will get 15. So that's encouraging. So if I take this 5 and multiply it by 3, I have to do the same thing to the top. And so what I'll get is 2 times 3 is 6, 5 times 3 is 15. And so you can see that these are, when I compare it to the other fraction I had, not equal. So in other words, you could say they're not equal with a line through them like that. Now let me ask you a bonus question. Which one of these fractions is bigger? The 9/15 or the 2/5? Well, the 2/5 we said was equal to this. This looks smaller than this because now that they're on the same denominator, I can just look at, I can say, well, I have 6 pieces out of 15 and I have 9 pieces out of 15, where this is the bigger fraction. And we're going to do a few more problems a little bit later on comparing to that. All right, so we did quite a bit so far with trying to find a common denominator just to see if two fractions are equal. It's the best way to do it. There's a few other ways. Your teacher could describe a few other ways to figure out if two fractions are equal, but personally I think doing it this way is the best because it really gets you understanding the idea of common denominator, gives you a good understanding of what a fraction really is. The next thing we want to do is talk about, when we talk about simplifying a fraction, you might hear that in your book as a fraction simplification or simplifying fractions, or even sometimes you see making a fraction into lowest terms, a lot of times you see. Let me show you what I'm talking about. We already, and I can actually do it right here, we already established that 5/10 is equal to this fraction, right? And we already established that 1/2 is equal to this fraction, right? So it stands to reason, we already talked about it, that 5/10 is exactly equal to 1/2, right? So if I have a fraction in a problem, or if I add some fractions or something, and I get 5/10 as the answer, that's the correct answer. That describes the answer right. But when you change it over into this form to make it an equivalent fraction, that's a small, smaller numbers involved, then that's what we call fraction simplification. You're not really changing anything, you're just changing the way the fraction looks. So let me show you by way of an example. If I want to basically simplify fractions, then I might have a fraction like 5/10. And I might ask you, see if this fraction is simplified, and if it is, tell me, and if it's not simplified, then go ahead and simplify it. What you need to do in order to simplify a fraction, you can draw pictures and stuff, but that's just going to end up making things difficult. What I told you a minute ago up here in the previous section is that you can multiply or divide a fraction by any number you want as long as you do it to the top and the bottom. So what I'm going to do, just by example, I'm going to show you. If I take this numerator and I divide it by 5, then I must also divide the bottom by 5. When I do that, I'm not changing the fraction, I'm just sort of changing the way it looks. 5 divided by 5 is 1, 10 divided by 5 is 2. So what I've proven to you is that 5/10 is equal to 1/2, which is already what I've shown you over here with pictures. So I'm using some of the same fractions to kind of drill it home that you're not really doing anything different. The way you do this, and you can in the beginning do it exactly like I have written out like here. If you want to see if something's in lowest terms, then you try to divide the top and the bottom by any number you want to make it simpler, and it has to divide evenly. Let's look at another fraction. Let's say we have the fraction 6/7. That means I have 7 slices of pizza. I divide a pizza into 7 slices and I take 6 slices away. Is this fraction in lowest terms? And the answer is it already is in lowest terms, because I can't divide the top and the bottom by the same number to make this any simpler. I mean, if I try to divide by 2, yeah, I could do that up here, but I can't divide 7 by 2. That doesn't divide evenly. I can't divide any single number into the top and to the bottom of this fraction to make it simpler. I can't divide this by 4, I can't divide it by 5, I can't divide it by anything but 1, or 7, and if I try to divide this by 7, then I'm going to get something that doesn't go evenly. And if I divide by 1, then I'm going to get the same fraction that I have already. So it doesn't do anything for me. So this is already simplified. Basically, you're always going to want your fractions to be simplified. When you add them or subtract them, you're always going to check to see if they're simplified. Let me give you another example of a simplified fraction. What about 4/5? You just look at it and you say, well, what number can I divide into the top and into the bottom, both at the same time, and make them divide evenly? Well, there is no number. If I divide by 2, yeah, that works here, but I can't take 5 and divide it by 2 and get a nice even division. I can't divide this by 3. I can't divide it by 6. I can't divide it by anything. So this is already simplified. Already simplified. And you can write that right on your test. If your fraction is fully simplified, you can write it like that. Now, let's get another problem. Let's say I have 4/8. So you look at that and you say, well, can I divide the top and the bottom by the same number? And the answer is actually you can. If I take and divide the top by 4 and divide the bottom by 4, then what I'm going to get is 4 divided by 4 is 1. 8 divided by 4 is 2. So it turns out that 4/8 is the same thing as 1/2, which is the same thing as 5/10. So you see, there's tons of different ways to write half of a pizza. I mean, I can divide the pizza into 16 different pieces. If I take 8 of the pieces away, I've got 1/2 the pizza. If I take a pizza and divide it into 100 pieces, but I take 50 pieces, I've still got half the pizza. If I divide the pizza into 1,000 pieces, and I take 500 of those pieces away, I still have half the pizza. So simplifying fractions is just sort of getting it into the simplest possible form, but really describing the same amount of pizza all the time. All right, so let's say I've got, instead of 4/8, what about -4/10? Don't worry about the fact that it's negative. That has nothing to do with it. It's just something that I owe them pizza instead of having pizza. So I try to divide top and bottom by something. Well, I can divide the top by 2 and the bottom by 2, and they both go evenly. And so I'll get -2 on the top, because -4 divided by 2 is -2. On the bottom, I'll get 5. So -2/5. What about 3/21? Can I divide the top and the bottom by something and make it go evenly? Well, sure, I can divide this by 3, and I can divide the bottom by 3. It has to be the same number. 3 divided by 3 is 1. 21 divided by 3 is 7. So that's the simplified fraction. What about, let's go over here. What about 3/24? Can I divide the top and the bottom by something? Well, I can divide this by 3 and this by 3, and they all go evenly. And so the answer I'll get, 3 divided by 3 is 1. 24 divided by 3 is 8, so 1/8. So 1/8 of a pizza is the same as 3 out of 24 pieces of a pizza. What about 12/24? 12/24? Well, you may not know what to do first, but let's say I divide this by 2. Okay, so let me go and divide the bottom by 2. So what I'm going to get is 12 divided by 2 is 6. 24 divided by 2 is 12. But then I look at this again and I say, well, I can still simplify that further, because I can divide this top by 2 and the bottom I can divide by 2. Again, you can continue simplifying as many times as it takes. 6 divided by 2 is 3. 12 divided by 2 is 6. But then I look at this 3/6 and I say, I can simplify that even more. I can divide by 3. I can divide by 3. So 3 divided by 3 is 1. 6 divided by 3 is 2. So 1/2. 1/2. And then you realize, and you hit yourself in the head and you say, oh, well, I could have started at the beginning. I could have divided by 12 here and got 1. And I could have divided by 12 here and got 2. I could have skipped all these intermediate steps. So when you simplify a fraction, it doesn't really matter what you divide by. Just pick a number. You don't have to pick the perfect number. Just pick anything that can divide into the top and the bottom. And then when you get what you get, you see if you can simplify it again. You keep doing it again and again. Eventually, you're going to get down to something really simple, and then you stop. All right, what about 5 2/4? So here's something interesting. This is a mixed fraction. Don't get too worried about it. It just means I have 5 whole pizzas, 5 entire whole pizzas, plus 2/4 of another pizza. So when you're simplifying these fractions, basically all you do is simplify the fractional part. So you can say this is equal to 5 and 2/4. But I'm going to divide the top by 2 and the bottom by 2. You don't really mess with this because that's just not what you deal with when you're talking about simplifying fractions. You only deal with the fractions. So you have 5. 2 divided by 2 is 1. 4 divided by 2 is 2. So 5.5. Makes sense. If I have 5 whole pizzas plus 2 out of 4 pieces, it's the same thing as 5.5, pizzas. What if I have -4 and 12/18? 12/18. Same thing, if I'm simplifying the fraction. I'll just keep my -4 along for the ride, and then the 12/18, I try to simplify that. And can I divide that by anything? Well, I can divide this by 6, and I can divide the bottom by 6. So I'm going to have -4. 12 divided by 6 is 2. 18 divided by 6 is 3. And that's the final answer, -4 and 2/3. Simplifying fractions are incredibly important. It's incredibly important. You'll be doing it all the time. So anytime you do any operation on a fraction, if you multiply a fraction, which we'll learn later, if you divide fractions, if you add them, if you subtract them, then you always should check to see if they're in simplest or lowest terms, if they're fully simplified, which just means, can I pick a number and divide it into the top and the bottom evenly? If I can, do it. If I can't, then it's already simplified. That's really all that means.